Hello friends, today I want to show you how you can build a C program that can compute a chi-square value. So here we go. You open your environment and include the libraries that you need. Hash include stdio.h. We also need a math library, math.h. So we are going to use functions. So this is a function to capture data or observations, and it's going to accept parameter for rows, columns, and observations. Observations, a two-dimensional array. Then for printing data, all the tables that we have entered. So this is a function to print data. It's going to accept parameters, row, column, and observations. Then we are going to use a function to get a function that computes expected values. And it's going to accept parameters row, and expected values. Then we are going to get a function that computes the chi-square. So we can go to our main function, int main. So in our main function, we are going to need a variable to store our rows, to store our columns. Yeah. And now we shall just print a message for the user. And then we shall capture the rows and columns from the keyboard. But before that, we declare variables for observations, for expected values, and then for the chi-square. And chi-square is initially 0. Then we shall capture the rows and columns. A new line, and on a new line, enter rows and columns. Yeah, enter rows and columns on a new line, and we get them from the keyboard. Store in row and store in column. Then we shall need observations. So enter observations. Yeah. So now we shall need a function to capture our data. So it is that, and it accepts rows, columns, and observations. So we shall need iterations I and j and a for loop to help us capture the data. So for I equals 0 to I less than row, and this is I plus plus. And then for j equals to 0 to j less than columns, then j plus plus. So we shall capture the data, and this is observation in position ij. So we refer to I plus 1 since they start from 0 and j plus 1, and then capture the data using a scan function. Yeah, that is our function that is going to help us, and then we are going to capture the observations. So data, we are going to pass in the rows, pass in the columns, and then to pass in observations. Yeah. Now the next thing we are going to do is to print the observations. So we are going to need a function to help us capture, to help us print the observed values table. So we shall need that function called print data. So we shall need that function, and we initialize, we declare I and j. So we shall need a for loop. So for I equals to 0 to I less than 0, and then an iteration of 1. Then for j equals to 0 to j less than column. This is j plus plus. So we shall print the data. So we are going to print the observations. So it is percentage. Let's take one decimal place and put a tab between those numbers and refer observations. Observations in position I and position j, and then outside here we go to a new line whenever we reach the last column. Skip 2 lines. So that is the function. So we can go back and use it in our main function. So it is called print data, and it accepts rows, column, and then observations. So the next thing is to find expected values. So the next thing is to find expected values. So expected values, we are going to use a function called expected data that we declared earlier. So we have that function that can help us. So for expected values, we're going to get the indexing numbers I and j. Then we shall find the sum for the row figures and to be stored in that variable. So initially the row sum is 0 for each, and we shall need a variable to store the column sums, and initially the column sum is 0. Then we shall need the overall total, which is initially 0. Then we shall need a loop to calculate row sums. So this is a loop to help us. I starts from 0 to I less than row, which is I plus plus, and j starting from 0 to j less than columns, which is j plus plus. And then we shall get our row, the initial row, because we are summing. So row equals to 0 plus observation inside. And then after getting it, we store it in row sum, other sum in position I, and it is row sum, and we redefine row sum to be 0. So let us find the column totals. So we are getting the column sums. So since we are fixing columns, we shall start with a loop for columns. So to j equals to column, this is j plus plus, and then for I equals to 0 to I less than row. Then we shall compute the column sum, and initially it is 0, so plus observation in I, j. And then after finding it, we store it in a variable called csum, and is equal to that computed column sum, and we redefine column sum to 0. Let's get the overall total. So we are going to get total is initially 0 and is equal. So total equals to 0 plus observation in ij. In ij, so we calculate expected values. So we know that expected values so we have to so expected values expected ij equals to the column sum in position j so the column sum in position j times times the row sum in position I divided by the total. So we go back and put the function in our main program. So it will be called expected data. So it is called expected data, the function. It will accept row, accept column, accept observations, and accept it will accept the expected values. The expected values. Then after we shall print the expected values table. So we shall use a function called print data and it accepts row, it accepts column, and it accepts expected data. So we have to compute the chi-square value. So the chi-square, we shall need a function called get chi-square, and it's here, it was declared earlier. So a correction here, the expected data. So let's go to the one for chi-square. So the chi-square function accept I for the rows and J for the columns. So we shall need chi-square, and initially it is 0, so we shall get a loop to help us do that. So the chi-square equals to chi-square plus observations minus expected values squared. So shall need observation I J minus expected values I J and then power 2 then divide by the expected values in position I and J. Yeah. And then after that we return chi-square. We return it. So we go back to our main function and print the chi-square value because it's what we wanted. So in our main program, to 3 decimal places, and it will be given by the get chi-square function, and it will accept row, column, observations, and expected values. Yeah. And then after that we can return 0 and exit. Yeah, that is our function. Let's run it. Oops. So this is line 95. Yeah, we did not terminate somewhere in our chi-square function here. Yeah, there we are. You enter the number of rows, number of columns, and then observations. 3, 2, 3. Yeah, it's done. This is the observations table, and this is the computed expected values table, and this is our chi-square value. Thank you for watching.